Hello everyone, welcome to the channel and I hope everyone is doing good. So in today's video, we'll try to understand how we will design the enterprise level RAG pipeline. So we will focus on the enterprise RAG architecture. So in the previous video, you have seen multiple scenario based question, multiple interview question for the RAG. You've also seen how to test the RAG pipeline, how to evaluate the RAG pipeline. So now we'll use all that knowledge and try to understand that how we design the enterprise level RAG architecture. Building a POC level RAG architecture or building just for the POV is very different. But when you go into the enterprise architecture, you have to just keep multiple things in the mind. You have to look about the security. You have to also think about the scalability of your system. You have to think about the performance of your system from multiple ways, integrating multiple sources. So in this video, we'll talk about all these aspects. I'll touch each of the section as an overview. But if you want the detail of any of the particular section, you can post it in the comment. You can post your doubt in the comment. I'll just come up with the next video detailed into that section. And guys, if you have not subscribed to my channel, then please do subscribe to the channel and share this video and channel to your friends and colleagues who want to transition their career into data engineering or want to come into the GenAI pipeline or just want to uplift themselves into a better data engineering topic. So this is the enterprise RAG architecture which I have come up with my previous knowledge. I have looked into multiple documents, and then I think this is the most simplified and will be the correct version if you want to build any enterprise RAG pipeline. So if you're in a lower year of experience or in the mid-level year of experience, if you're not a full-fledged architect, then you may not be involved in all the section of this particular architecture. But it's good to know everything as an overview so that you can contribute in this call, in the architecture call, and can also put your points and understand the whole thinking behind this. So you can see like there are two major pipeline. The first is data ingestion indexing pipeline. So this portion is data ingestion, and indexing pipeline. Then we have query and serving pipeline where the user put the query. Then there is a foundation layer. So in the foundation layer is something which interacts with commonly with the query or serving pipeline. Then we have another section which is operational section, which deals with security and governance, which deals with monitoring, which deals with evaluation framework. We have seen the evaluation framework in the previous video. Now we'll talk about the data ingestion and indexing pipeline. So data ingestion and indexing pipeline is the pipeline from in which you ingest the data. You get the data from multiple sources, you put it in some place, do the proper filtration, do the chunkings, then create the embedding out of it, and then put it into vector database. Now, you see there are multiple division which I have created in this data ingestion and indexing pipeline. The first is data source. For getting the data, first of all, you need to look into the multiple data source. Why I'm talking about a multiple data source? Because in the RAG system, multiple data source becomes very important, because when you're creating something on the RAG or the RAG application on some of the data, that data comes from multiple systems. For example, you are trying to create a RAG architecture or create a RAG pipeline on the ticketing tool. Means you want that your GenAI or your AI application should give you the information or the root cause of the similar kind of issue in your system. So in that case, you need to get all the Jira ticket, you need to get the all the emails, you need to get the all the Confluence page which contains all that problematic situation or history problem of the production support. So few of the data sources which I have listed down here is SharePoint. SharePoint multiple data is getting dumped into SharePoint. That can be one of your data source. And when you have to connect to the SharePoint data source, you need to have a SharePoint connector, or with a normal Python programming also you can do it. Then the Confluence, many companies keep their information in the Confluence. For example, you are trying to deal with the company policy, then few of the information can be in the internal Confluence of the company. Then S3 bucket, file system, APIs. If you want to get in some of the data from multiple website, you need to write the crawler, and or some other team will write a crawler. You will get the information out of the APIs. Then through emails and through the Jira ticket. These are few of the sources. So once again, I'm saying, like in this kind of architecture, in where you're building the AI application, there multiple sources will be involved in almost all the cases. You will not deal with a single source, because you need to get the information from multiple sources to create a simplified and logical answer out of it. Right now, we'll go into a different section, which is ingestion pipeline. Now this is the data source. Now how to get the data from the data source? You need to create a ingestion pipeline. If you have already worked in a data engineering field, then you know you will be understanding what I mean by ingestion pipeline. You need to create a pipeline which will automatically get the data from the data source and put it into some other place. So for SharePoint, you can have a SharePoint connector. You can schedule the particular job. You can have the incremental. You can have the change detection. For example, you are getting data from S3 file, and if there is a change in the schema or change in the structure of the file in S3, you will again ingest it. So there must be some mechanism to understand that change. So the whole purpose is you have to create some pipeline, some automated things which will get the data from data source, and you can put it into any of the places. For example, you're working in AWS, then you can put it into AWS S3 bucket. After getting the data in the ingestion pipeline, you will go with the processing and chunking. Now, what happens in the processing? First of all, you are getting data from multiple sources. So you have to either make it in a simple singularity, means bring it in the same kind of format, or at least the logical meaning should come in a same form. So for example, you are getting multiple documents, PDF documents. For example, in the insurance company, the insurance things are stored, or insurance a person insurance, the details, for example, car insurance, the accidental coverage, what happened at particular date, all the information are in the PDF format. So for getting the information of the PDF, you need to use OCR. That PDF will be scanned and all the text will be extracted from the PDF. So parsing and OCR is important. If you have a XML, if you have a multiple nested JSON file, then your parsing will be required. Your data need to be cleaned and normalized. The data which is not actually required need to remove from that particular data source. Then metadata extraction is very important. For example, getting the information about department, getting the information about currency, getting the information about the policies in the metadata extraction. This is important so that you can actually combine the metadata information with the data when you generate the answer from the vector database, so that security will be involved, a restriction will be involved when the knowledge is being shared out of the vector database. I'm not going very deep into it, how the metadata extraction works, what is the actual use case it happens. So if you want me to get into any of the particular topic in very detail, then obviously I cannot cover it in this video. So you need to post it in the comment. I'll surely come up with the next video with that topic. Then in this processing, when you have done the processing, then chunking strategy. There are multiple chunking strategies. One is on the paragraph wise. You can chunk on the paragraph wise. You can chunk on the logical frame. If a particular two lines are making the same logical, then you will keep in the same chunk. You will have the overlap of the chunks. Some of the information of one chunks will be there in the other chunks. Some percentage overlap will be there, so that the continuity or the semantics of the sentence be continued in between the chunks and chunks. It should not get break. So chunking strategies, I have already written it wrong. CHUN. So you can look into my previous video if you want more detail. Obviously, you have to put it in the comment. Then once you have got a proper chunk, then you have to go with the embedding. What is embedding? Embedding is creating a multi-dimensional vector on the top of your information, of your top of your data. So this data is data which we understand, but vector database will not understand that. We have to assign numerical number to each data chunks, so that similar meaning of the chunks remains near to each other. For example, entertainment and movies are very similar in the way of meaning. So the number assigned to the entertainment will be very same or near to the number assigned to the entertainment or movies. Okay. So you need to look into, there are many embedding models available in the market. Once the embedding is done, you can store into vector database. Pinecone is there, OpenSearch, PG Vector. There are multiple vector database where the embedding and the storage of the embedding can be done in the same way. Like you don't have to generate the embedding outside. But the enterprise level things becomes very different, because in the enterprise level chunking strategy matters a lot. Your embedding generation matter. The model selection of the model for the embedding is very critical, and choosing the vector database as per your application is very critical. So I have kept embedding outside of the vector storage. So now this complete your indexing. Indexing means that assigning the number to your chunking, like creating the embedding and storing the vector database that itself in the indexing. So this is the data ingestion and the indexing pipeline. Now we'll move to another pipeline which is called query and serving pipeline. So now the another pipeline is query and serving pipeline. So the first is the user, when the user which writes the query, right, the prompt actually. It can be through the web also, API also, or a chatbot, any of the application which may be using this particular RAG application. So the first thing is to understand the query. Like what is the, like user may write the query in multiple ways. So there must be some mechanism which will rewrite the query in a better way, which your system will understand and can give the more accurate near to answer. The second is to understand the intent of the queries. Like what is the intent? Is it a questionable question, or it is just a R&D question, or it's just a discussion question? So we need to understand the intent of the question. And the third thing is to apply the metadata filter. Filter means depending on which domain the question has been asked. If we can apply and understand a particular domain which the user or the API has asked the question, then it will be better to retrieve the better information. Then we have the another kind of things. When we have formed the queries, then the hybrid search. That query, the purpose is to search that query inside your vector database. So in the enterprise level, generally we don't fire all the query directly into vector database. The result can be missed. So we use here hybrid retrieval. We have already discussed. One is the text to text joining text to text retrieval, means matching of the same sentence, same word. For example, AWS equal to AWS, that kind of matching will be done. And other is the semantic retrieval or semantic matching, in which AWS equal to AWS cloud, or data engineering cloud. A similar kind of meaning can be searched. So my purpose is set up the system for the hybrid retrieval. Then we have re-ranking. Re-ranking, we have already talked about the ranking in the previous video. So re-ranking, these are the ways you can refine your search. So re-ranking will refine your search. You will get multiple chunks. So top 50 chunks, or top 50 documents, top 10 documents. Re-ranking is very important to increase or to have a better retrieval, the top retrieval of your from the vector database, so that the most if we most what you call similar meaning document or the chunks are together, and so that that can be sent to the LLM, and LLM will create the most refined answer out of that relevant chunks. So re-ranking is one of the ways for performing it. So in enterprise, you use a aggressive re-ranking or not, it doesn't matter, but you should have that mechanism, so that in case your RAG architecture is hallucinating or there is some issue in the performance, then you can go in the re-ranking module and try to do the things. As I have told in the starting of this video, you have to think of a scalable system. So re-ranking, hybrid search, these are just the future option. It may not be required in the current situation, but that placeholder should be there at least, so that you can come there and rework if something is required in that area. Now the other thing is context assembly. Means after you got the chunks, so before getting into LLM, you make them understand, put the information like what is the context. Like this is a medical context, or this lies into some particular domain, or you have to answer keeping these all things in the mind. Or you can add multiple things. You can add citation here. You can add any documentation, document field reference in this stage. Now, the other thing is LLM inference. LLM inference means you have to use multiple models, and just this is all about selecting the LLM model for your domain. And then there is guardrail and response. Guardrails is very important because you may be dealing with PI data, the data which is very sensitive. You may be dealing with some finance data. So how to protect that data, or you have to also protect your system from the prompt injection, from multiple prompt coming at the same time, from the workload perspective also, from any hacking perspective also, or any of the very absurd response from there also, you have to protect your system. So guardrails is very necessary to build put in place when you are doing on working on enterprise RAG architecture. Actually these guardrails is there in all kind of system which is at the enterprise level. Now, once you get this, now for helping to get the answer, you have some foundation layer. Means caching layer is there, where you cache some of the output of your prompt. You also cache the prompt, which will be helpful in the future retrieval of the data. You have a model gateway, So you decide you decide on the query, like which kind of query is that, and then if it's a small query, why to use the larger LLM model. So in that case, you can go with a smaller LLM model so that you can reduce the cost. So that all decision, that all checks you have to give in a model gateway. Then you have prompt and configuration management. Like if the prompt, you want to put some configuration on top of the prompt, or with the help of model gateway, if you want to change a prompt in the configuration, that you can do it here. Then you have workflow orchestration. Like when you have created all this thing, how you will run all this thing. Everything is connected to each other. You need to schedule it. With the help of some tool, you need to create a workflow. So for the workflow, you can have LangChain, you can have LangGraph. With the help of that, you can use GCP vector, what do you call, the vector AI, with the help of GCP. So that will create a workflow, and there will be orchestration tool like Airflow, Autosys, where your workflow can be scheduled. Then you have a storage layer where you may keep the intermediate input. You may keep the data source, which is also coming, like after ingestion, you can keep it in the storage layer. So this we covered data ingestion and indexing pipeline, query and serving pipeline, foundation layer. Now there is across this horizontal, we'll have one thing called security and governance. So this guardrail is for the information. Security and governance is for like managing the user, which user is logging to give the query, which user has the permission for particular department. Like if I'm asking a question from a finance department, and if I don't have a permission to ask a question in that thing, so that needs to be taken taken in the case of security. Governance should be put. Governance means rules, protocols for all this process. Then monitoring and observability. For all this thing, you need some dashboard, some system which will monitor each thing, like how much percentage of output it is giving correctly. Is there any pipeline break? Is there any workload increases? What is the token everyday token exhaust, or what is the token cost every day? What is the you can put the slab threshold slab on the costing. Which model is, like in the model gateway, we are putting multiple model name, then which model is performing better, which model is being costly. So everything you have to put in a monetary and observability framework. Then you have to create a evaluation framework, like what we have seen in the previous video. For evaluating all this pipeline, you need to have a framework which will give you the information, like is your RAG pipeline hallucinating? If it is hallucinating, then what is the problematic area? How is the ingestion rate? How is the response rate? So these all things will be done in the evaluation framework. So I think you'd be getting overall of all this thing. So whenever you have to, in any of the interview, you have to explain the RAG architecture, I will suggest you to go through this, take the screenshot of this, and then you can go through each point in detail. For example, you want to learn more about what is hybrid search, go into it. You can Google the details. If you want me to explain this, you can put it in the comment. I'll come up with another video. I hope this will be useful to you. If you like the video, if you like the content, if it is helping you, then please do post in the comment, like, share, and ask your friend to subscribe this channel, and you also subscribe this channel. We'll meet in the next video with the next topic. Till then, happy learning and goodbye.